Hey, so thank you for joining and participating today. My name is Alan Clark. I am in the office of the CTO for SUSE, and I focus on new initiatives in the open source arenas and track some of those technologies. And today I wanted to talk about safe cloud native security. And what I'm introducing here is actually a new open source project that SUSE is introducing into the open source world through an acquisition called NuVector. The technology is actually very robust and mature, but it's been private. It hasn't been open source. So we're in the process of doing that now. And so what I'm going to talk about today is that technology. We'll introduce that technology, but just be aware. And then I'll talk about more about it being open source and where and so forth at the end. But I picked cloud native today because, as I mentioned earlier this morning, got a huge adoption rate of cloud native services coming into the business world. Within critical services for corporations and vendors of services. And it's kind of interesting because we've relied on a lot of technologies like firewalls, but what you find is you adapt cloud native, those technologies are good, they're not bad, but they're not sufficient. So I'll explain that as we go along here. But so we've got a lot of adoption, as I mentioned, right? A lot of containers are moving into our production environment. So we've long past the trial period of throwing things and building containerized services and putting it in our sandbox for tests. We're now into real-world productions, rollouts of containerized services and microservices out into real-world production, right? And so they're playing with and leveraging data and creating data that is critical to businesses, and it can be very sensitive to businesses. So not only can it mean a loss of money to a company, but it also means you can have a loss of things like PCI compliance, for example, right? And so we need to be very cognizant of that. And as I mentioned earlier, in a containerized Kubernetes-based world environment, your traditional security tools like firewalls, intrusion detection, malware scanning, those types of tools are great, but they're not sufficient with your containerized world because Kubernetes does some real clever things like abstracting away the network constructs, right? And so those traditional firewall tools and so forth can't detect what's going on in a containerized network environment, right? It just can't see in. So not being able to see, it can't provide you the protection that you need, right? And it can't determine if there's actually an attack happening. And so that's why you need a solution that's actually designed for cloud native architectures. Now, when we talk about security, the attack surface, a lot of times we think about hackers hacking into your runtime environment, right, and making their attack there. But the attack is not just about the runtime. We need to look at the whole process, the whole pipeline from build down to production. Or think about it, as your supply chain. And critical vulnerabilities can enter at any phase of this environment. But it all starts clear back, if you think about it, it all starts clear back with the build and test phase, right? And your developers are building container images. Perhaps they're bringing in open source for their applications. They're bringing open source from the outside. And quite frankly, we can go from there down to the runtime where there might already exist vulnerabilities in your production. So, because we discover new things all the time. So we need to be able to detect, manage, and remediate vulnerabilities end-to-end, from the beginning of your builds all the way down through the full life cycle in your runtime environments. Now, some of the tools that are being used, like Kubernetes or just things like your registries, David mentioned that this morning in his keynote, right? All of these things in your pipeline can be points of attack. And as David mentioned this morning, that's actually one of the typos or one of the big keys, right, that people are using to make attacks into your environment. So, so one of the biggest common errors is misconfiguration. And that's what can create tainted images. So we need to be careful of that. Now, second part here is we got to think about, so as we add in security, we want to put the controls in place, but we can't slow down the pipeline, right? One of the big advantages that is always touted with cloud native is the whole agile development model, right? Where we're building and developing and releasing stuff very quickly. So we're updating those, we're pumping them out, hundreds or thousands of times a week, whatever you're doing. And if you think about it, if you need network connections and so forth, you don't want to have to go in and say, hey, I got a network connection that's required. I got to contact the firewall team, et cetera. That's a slow process, and it's going to take days. So we need a quick environment, and we need to be able to patch quickly. We need to be able to detect quickly and not slow that process down. So whatever we do here for security purposes, we don't want to slow down the pipeline. And then finally, the other thing to think about here is, going back to our runtime, is in our production environment, we need to be able to detect vulnerabilities that are running, because things happen, right? We discover new attack surfaces and vulnerabilities. The CVEs get updated all the time. So we have to be able to update that environment as well. So it's not that we just, hey, we built something, it's secure, we're done. We need to monitor and update that runtime environment as well, right? So we're going all the way through the pipeline here. So what do we do about it? Well, to delve in a little deeper here, we kind of look at it as this full lifecycle security has multiple layers to it, right? So the attack we have on this is a layered model where we're not just relying on one security method, right? We have a whole series of those, and we break those into two buckets, essentially. One is around the secure chain, let me try that again, supply chain security, and then the second area is around the runtime security. So as we look at those, if we look at the supply chain security, we're talking of things like vulnerability scanning. Try to say that 3 times. Vulnerability scanning, right? We're scanning those images as we build them to prevent exposure, entry exposure, right, into it. We do things like compliance scanning, where we're looking for embedded secrets in the images and containers that we're building. And then we build what's called admission control. And I'm going to go into depth into these a little more, where we use admission control to control what gets put into our runtime. So even though we've perhaps scanned our images when they've been built, we've done compliance scanning, looking for embedded secrets and so forth, we still want to have control as to what goes out into our runtime. So we call that admission control. Then, of course, we look at runtime scanning, which are things where we're looking for newly discovered vulnerabilities, right? So we've been running this image for who knows how long. All of a sudden it comes out that, hey, there's this well-known bug, log4j or whatever, and we need to patch for it, need to update. Then there's things like threat-based controls, where we're looking for ways hackers might abuse the network. So this is things like denial of service, injections and so forth. And then another concept here that I want to add in here to talk about is what we're calling zero trust controls. And this is actually kind of a different approach, or a new approach that SUSE has into this space, where it's an exception-based control. So we're kind of doing the opposite of what the market tends to do, and that is they like to set up rules that says we'll allow everything but this. We're going the opposite. We're saying you're taking out everything but this, right? So we're setting up exception controls or declarative based controls. And so if we delve down a little deeper, let's look at, for example, let's start with the vulnerability and compliance management of this, okay? So as I talked about this lifecycle container security, what I was really talking about here is we're starting with vulnerability and compliance management. And this starts early in the developer's arena or the developer range, and it continues on down through to the runtime production. So the first part of this is build scanning, and doesn't really matter what tools your developers are using to do their builds, whether they're doing Jenkins or Circle CI or Azure DevOps or GitLab or whatever. You get to a point where the developers are building and submitting their container images. And at that point, we want to do vulnerability and compliance scannings, right? So when they make their builds, we want it to automatically trigger this vulnerability scan. And that scan will help us to determine if there are any issues or vulnerabilities that we know about that are being put into their components or their libraries. Now, at that point, when we do that vulnerability scanning, you can then fail it or reject it and catch that vulnerability early, right? So then the developer has the opportunity early on in this stage to go back and remediate, or we can force them to go back and remediate the problem long before it gets further down in our pipeline. Then the next step here is when we get past that build, we've got the image built. What typically happens is those images are placed into a registry, right? And those images could be internally built, or they could be externally sourced, so forth. And you need to continually scan the registry for vulnerabilities, because it may have passed your build pipeline, but a vulnerability has been discovered that wasn't known when the image was originally built, right? And originally stored. And so this registry scanning keeps getting updated. So we're continually updating our scanning materials for our CVE database as part of our scanning component, right? So that we catch all the new issues and vulnerabilities. So even if it gets to where you've built the image, we're seeking those out and trying to detect those as quickly as we can in the process, not just waiting till clear at the end in production. Then we also look at things like the CIS benchmarks and custom audits, and we make it so you can essentially run any type of benchmarks to make sure you haven't misconfigured some aspect of your system, such as Kubernetes or your Docker daemons or any of the containers that are running, right? And this is actually a point where you can begin to inspect for secrets or for open file permissions or other types of compliance violations, right? So by being able to do these benchmarks and tag those and audit those, this enables you to help produce compliance reports that help with your PCI or GDPR or NIST auditing. Now, it's interesting to note that the cloud native environment, PCI compliance and well, the PCI compliance auditing firms, for example, are still kind of catching up to this idea, and up to the idea of, you know, what does it mean to be segmented and put in segmentation for credit card data, et cetera. So, and what does that mean in a containerized environment? So there's still a lot of education that needs to be done in this, but we've got a good step forward with these types of reports to help with the auditors. And then, of course, as I mentioned earlier, when we reach that runtime environment, we're into our production, right? And we're running Kubernetes and containers. We want to be able to detect and remediate anything that's really recently discovered, right? Vulnerabilities, and then we want to be able to automatically quarantine a container if it has a critical vulnerability. So we want these capabilities, you know, along the whole spectrum here. So now if we expand a little bit on the ideas of runtime protections, I mentioned earlier that we have this notion of admission controls. Okay, so admission controls, think of it as a gatekeeper. So it is the gatekeeper between our build and our CI/CD test pipeline and into the runtime environment. This admission controls is where we can set up rules that says, you know, things like don't allow critical vulnerabilities that have been discovered in the last X number of days, or you know, so we just set up these rules, right? So we can set up rules and such that perhaps we'll catch things that the developers hadn't caught because their environment wasn't quite in sync or whatever. But think of this guy as our gatekeeper. And then, so he's a gatekeeper, but he's also a threshold level security, right? So your threshold here might be higher than perhaps what the developer had in his site. It might be set up a little different, but you're not just trusting the developer and what he had set up to catch those vulnerabilities. You're setting this gatekeeper up, right? And basically it says, we're not going to allow anything into our production environment if it fails our criteria from this gatekeeper, right? So it's kind of a critical piece. Once we get past the gatekeeper, this is where our traditional security controls, as I mentioned earlier, we want those and they need to be implemented, but we need additional security controls, right? And this is the model where we have implemented things that we call like the layer 7 container firewall. This is specifically designed for Kubernetes and containerized environments. This firewall, unlike your traditional firewall, can actually inspect network traffic within a Kubernetes environment, whether that network traffic is east-west, pod-to-pod, ingress and egress, and it can just look for any type of violations or network attacks, right? So it can see in where your traditional tools can't and catch those. And then the container workload security is the technique we use for inspecting and monitoring any of the running containers. And this system makes sure that no unauthorized processes or file activities are occurring within those containers. Okay, so we're scanning within those. So this is where we have a little difference with our new approach that we call a zero trust approach, because this is where we define a list of allowed behaviors for your container. And so we define what are the allowed network connections, as I mentioned, the east-west, as well as ingress and egress, and what are the allowed process and file activities in that container. So we set up and say, this is what we trust. Anything outside of this, gets rejected, right? So everything else we treat as being untrusted, and it's blocked if we set it to that level, right? And this is one of the most crucial pieces that we find for detecting and trapping attacks at day 0, right? Or even beyond when the processes need to continue to operate. So this is kind of a little different approach than you've probably traditionally seen. Then the next area I want to talk about is how do you keep this all up to date? It's nice to create all these mission controls and so forth, right? But it's very easy to let them lapse and fall out of step. So this can be a big issue, you know, as you're, particularly if we're in the agile world where we're trying to deploy new applications or, you know, updates, and these could be hundreds or thousands or whatever, every week or every month, right? Whatever the frequency is. So how do we keep up this zero trust security model? And how do we keep up with this rapid development pipeline? So how do we do that? Well, we kind of look at it, and again, this goes back to what I mentioned earlier. We don't want to slow things down because we're adding security. So we kind of look at it and say the security policy should be a security policy as code, right? And then that security needs to be automated. And if you think about it, when you create your microservice and when you're creating your container or your application, you're basically creating a YAML file that's going to govern that deployment and how that application works, how many replicas it can have, and the configuration and so forth. So you're doing that in a YAML file. So we believe at the same time that there should be a security manifest that is declared for that service or the application. And that security manifest is really defining or declaring what the behavior of your container is going to be allowed and what it can do in that production environment. What the network connections that it can make, what process and file activities are going to happen, and so forth. So by managing your security as code, just like you're managing how you're building and what is contained and what that container can do. So if we're managing it the same way, checking it in, checking it out, updating it, all that, this is how you can easily keep up with these modern automated models, right? So basically what this enables us to do is securely automate and integrate the security policy as we're developing our services. So as a final note here, I notice I'm going to run out of time here really quick. As I mentioned earlier, what I've been talking about here is what we're calling OpenXero Trust. So SUSE is a full open source company. Everything we do is open source. And we recently, NewVector was recently acquired by SUSE. And so NewVector had been selling this security technology, containerized security technology, for quite some time before they were acquired by SUSE. And since SUSE is an open source company, we said, okay, it's time we turn around and open source that. And we're in the process of doing that now. So what we're open sourcing is actually a very mature, robust set of technologies. So it's not just, you know, raw, untested code. This is code that's actually running in production in some of our customer sites. And we're turning around and open sourcing that. And our mission, I should mention that our objective in open sourcing this is to further the creation of an open, interoperable standard for security integration with the containerized Kubernetes-based management platforms. And that's not just for SUSE. So this technology we support, SUSE, Rancher, of course, right? The SUSE technology, but we've got support in there for Red Hat OpenShift, VMware Tanzu, EKS, AKS, GKE, and so forth. So it's very robust across your microservices platforms implementations. And as we open source this, our mission, we're calling it OpenXero Trust, or OZT. So OZT's mission is to maximize the adoption of container security without locking you into a particular container management platform, okay? So we'll continue to support those third parties in addition to SUSE Rancher. And then our objective is to further the creation of an open interoperable standard for security integration for all container management platforms, right? So we're going to support all these platforms. So our goal is, our objective is to accelerate the adoption and build industry-wide collaboration. That's our goal. So that's why we're doing it. And as I mentioned, this technology is already in use, in production, you can go to New Vector's website, you can see their list of customers to see what type of environment it's already being used in production. So we've proposed this project. It's out there on GitHub under OpenZT. We've proposed this new project to CNCF as a new security-based project, so you can go see that submission. That has not been approved by the talk there, but it's in process for that. So the information I'm giving you today is very new. It's a very new project, but I wanted to bring it today to talk to you about it, just to give you that invite to come and join us and participate in furthering this technology. Like I mentioned, there's a lot of areas that still need work, right? The PCI compliance and so forth. So at the high level, just getting the world to understand how security works in a container environment, how the credentials like PCI and so forth, how the auditors can learn to understand that. A lot of stuff to do there. But again, in the code, there's even more work we want to do there as well. So we're probably about out of time. Yeah, I think we're out of time here. But that's my introduction. I invite you to go check it out and see how it works. I think we got maybe 1 minute. Any questions? Yeah. Are not efficient, so firewalls are not efficient? Yeah, dealing with. Yeah. Well, so a lot of this is so the question is around, let me try to paraphrase. The question is around the efficiency of firewall detection, network analytics, testing the egress, and so forth. Yeah, the traditional model was bigger and bigger firewalls, right? Correct. Yeah. So how do we get more insights without overhead? Yeah. Some of it, right? A big part of it is in the configuration, validating those configurations, right? Making sure that you're following the rules. Part of it is runtime scanning, right? Ensuring that the connections being made within the Kubernetes environment is following those policies, right? And so forth. So yeah, so it's a combination of things. So specific numbers on how much overhead that is, I don't know. I'd have to follow up on that. All righty. Yes. So the question is this all, so did you just take New Vector and open source it? And the answer is yes. That's what we're in the, that's, yeah, isn't that that's a wow. That's what we're in the process of doing. So there's still a little bit of work they have to do up there, but the code is there. They have a little bit of work to do in getting the build process and everything all set up. So, yes, it's the same code. We haven't hidden anything. All right, we got a flag. We're done. Thank you, everybody.